Virginia Dignum, Associate Professor at the Delft University of Technology in the Netherlands. I've been working in artificial intelligence for more than 20 years by now. The last few years increasingly in the direction of the societal impact and all the issues that come with it when the AI is really going to have and to be deployed into the world out of our labs and our small toy examples and really working in the world. So I'm working in issues of ethics and how to ensure that those systems are developed ethically and doing ethical things. And I'm also working on the issue of participation and inclusion. So we tend to be developing AI systems from the perspective of ourselves, which actually, if we are honest, represent at least 5% of the world. There is the other 95% of the world which have no voice in what we are doing, no profit, and probably will have a lot of the impact as well. So one of the issues which I work on is really see how can we ensure participation, not only of everybody which is directly related, but increasing that towards those ones who are not included, are not connected even, and how can we ensure that AI is not only taking their voices, but also contributing to a better world, if you want. My point is that humankind have developed a lot of theories about what it means to behave ethically, and those theories are in a sense very much not in contradiction, but they take different aspects of the whole context and they reach different conclusions. So my point is, if we are building systems to behave ethically, we first have to have a clear idea of what it means to behave ethically, and we don't agree as people about what is ethical or not. And another thing is that we claim we are building autonomous systems. Again, we don't really further specify what we mean by our autonomous system. And you were referring to the book of Stuart Russell. One of the examples he gives there is the thermostat. And so between the autonomy of a thermostat, the autonomy of a self-driving car, and the autonomy of a human, there are many gradations, many dimensions, which it's increasingly important to be able to describe, in my opinion, to formalize such that we can really validate or verify that the systems we are doing are indeed doing what we expect them to do. And that question of defining is for me very important. I think that we should start by identifying what are the characteristics of the different types of autonomy, the different types of ethical behavior. And then if we know that, we might be able to start linking that to different types of situations. But whether we'll ever make a recipe out of that, I doubt very much. We have not been able to do that for ourselves. But I think it's important to identify what are the environment for which we are developing it, what is the society, how is that society like, what are the kind of values which are important in that society, how does that society describes or understands those values, and how the system behaves there. I didn't really got much into details this evening, but there are several options concerning, for instance, again, the self-driving cars. One is to give all the reasoning to the car itself, which is one which is being developed by the Google car and whatever, so the car itself will be able to decide everything itself. Another kind of the other side, the more institutional side, is to give a combination of decision-making power to the car, to the environment. So in the Netherlands we are experimenting a lot with the smart roads, where the road itself has a lot of intelligence determine how the distance between the cars, the speed of the cars and so on. So the cars enter a kind of a convoy, so in which, in a sense, there is a shared decision-making between the environment, the institutions, the rules that are put in place, and the autonomy of the car itself. So there are many different ways of going about it, and I think we need to really identify and understand those different ways of dealing with it, and not focusing too much on can we develop a car which is fully autonomous at any possible situation that it will ever encounter. You can think of autonomy in terms of the actions, deciding on which actions you can do, but you don't have autonomy to decide on your own goals, on how to perform, how to achieve those goals. So there is, you can be autonomous in terms of what actions to take to achieve a goal, but not autonomous in terms of deciding your own goals as a system. You can be autonomous in terms of deciding which are your goals and then which are your actions. And you can even be autonomous in terms of deciding what are the motives which lead you to want or to desire a certain goal. So, and those are quite different and fundamentally different ways of looking at autonomy in systems, and which I think that in a lot of the discussions that we see around, including the discussions on autonomous weapons, is not really clear what is it that we are referring by an autonomous weapon. Is it a weapon that decides on its motives, or is it a weapon that decides on which actions it takes to achieve a goal that we or whatever army gave them. So and that's why I think that it's very important to have these discussions on, especially in these impactful things like autonomous weapons. But on the other hand, we should be careful on understanding what are the impacts of these different types of autonomy. My main concern is the transition phase, the moment in which we have as many self-driving cars as human-driven cars. I think that is where the issue of that's where it will be the main problems. Once we move into a situation in which the majority of cars are self-driving cars or trucks and so on, I think that indeed we can expect a much lower percentage of accidents in the road. Although, and that is actually one of your colleagues here at the University, one of the Australians here at the University of Melbourne, he has done some experiments with children in high schools here and putting this kind of discussions, like we have the trolley issues with kids in high school. And one thing which comes there is the humans adapting to the fact that the cars are going to be safe is going to make us more unsafe. And those teenagers in high schools right away by themselves come with the idea that how far can we dare the car? So we know the car will stop, so can I go across the road 1 meter in front of the car? Half a meter, 20 centimeters. So that's actually the kernel of the work that I do, is that as we build systems, those systems are built according to what we want, but they are changing our behaviors as well. And I'm not saying that behavior will be widespread, but it's just a very simple example of issues which are going to appear and which are going to change society because of the ways we implement those systems. So,
about hackability.
Sorry?
About hackability of because they're all computational systems, it's hard to hack people. It's easy to hack systems.
Yeah, you can, I don't know if you cannot hack people. I think it's a different way. People drive under influence. People drive in all kinds of very tiring and very stressful situations. So it's not hacking. Indeed, hacking is a problem. Safety, security is a problem. And that, I think, is one of the discussions that we really need to, and that goes a bit back to what I was talking about, moral overload. We cannot have everything at the same time. We cannot have unsafety and accuracy and fairness and all those values that we want. At a certain moment, there is a limit to what we can put together, and this is a decision that I believe strongly that we have to do ourselves and not leave it to the machines to determine it for us. And indeed, the more safe we make the systems, the less they will be able to interact with each other, so then the less they can potentially be efficient in what they interact or not, because the interactions is what can be hacked. On the other hand, the more we allow them to interact and to negotiate as you wish the way they cross a road or they cross each other in a road, those two vehicles, the more we are allowing for hacking. So it is a balance that we have to decide, and I don't think there is a solution which will be ever 100% covering all the different principles and values that we want at highest possible value. Yeah, I think that in a sense those are much easier. They are indeed for what I'm not an aviation specialist, but I understand that as we fly, that for 90% of the time it is automatic pilot which is flying us. And the most difficult technically is the interaction between those systems. So an airplane, in a sense, has much less interactions with other participants in the context than a car. And potentially it can have more impact because there are many more casualties than what with a car. But in a sense, I think it's probably easier to implement a self-flying airplane than self-driving cars, because the cars are not alone in the road and they have the people around and dogs and the cats and all those things. I believe, and it's not my own experience, but I have read that one of the things which they expect will be most quickly fully autonomous are sheep. The crossing the ocean and those container transports of ships in the sea, that those ones are the easiest to automatize. Easiest, AI self-improving, yes. Again, depends what we mean by self-improving, and now already the systems are improving themselves in small ways. The AI that is going to become superhuman or intelligence in a general way, in theory is possible, but I think that a lot of, again, is what we mean by being better than human. In a lot of things they are better than us. My calculator is much better than me on calculating a square root. My car is much better than me on going quicker around. So in a lot of things, all the technology that we develop is to improve us in one way or another. We are now reaching the moment in which we are developing technology that improves our cognitive abilities. What I think that, in a sense, is that whole exponential issue. I'm not really sure if it goes like that. In one end, there are mathematically proven limits to computation, so there are problems we can compute. Actually, there is a book here at the MIT Press which discusses exactly that. There are problems we can compute, and there are things which we know that we will never able to compute. So that it grows forever, it's not really necessarily so. And also the idea that if we learn how to do A and learn how to do B and learn how to do C and so on, at a certain moment we'll learn how to learn about all those things. I think that's a step which we still have to really very carefully look at. That machines will be able to do all those things, yes. That they will be doing many of those things sooner than probably we expect, yes. That necessarily brings machines to all of a sudden being able to know about knowing, that I'm not really sure how possible or how quick it is. On another hand, in the issue of machines which are conscious and so on, and here I'm quoting Joanna Bryson. I don't know if you ever spoke to Joanna Bryson. She's not here in this conference, but it's someone which has very good and is very well known in this area of ethics and consciousness. And I'm quoting her now. The moment we have built machines which we are morally obliged to treat as a moral entity, then we have done something wrong. And that, I think, I believe strongly in what she says. She says it much better than I would ever be able to say. And that, I think, is so. We are building machines to help us, to essentially being our tools, even the more efficient and smart tools possible, but they stay as part of our things that we use as people, and not machines which we will be morally which will be moral entities. That I think that that's an issue which I know that a lot of people have different ideas on this, but that's my point.